Hello and very good morning, students, to another video of laws of motion. So in the previous video we studied about how an unbalanced force can make an object move. Okay, we recall that once again. Suppose we had a box and we are applying force, then the static friction is also applying force on the other side, so the box does not move. In order to move the box, you have to go past that static force. So whenever there is an unbalance of the force, then only the object will move. But we will not go into that once again. And we move further. We move further to our first law of motion. But in order to understand the first law of motion, you have to first understand a simple experiment given by Galileo. I think everyone has heard about Galileo. So we find two planks kept on the either side of a very smooth surface. So what Galileo did was, he took two very smooth surfaces and kept them at equal angles. So suppose if this is 45 degrees, then this is also 45 degrees. Suppose, okay. So he kept two planks, really smooth planks, at the equal angle on a very smooth surface. This surface is really smooth. Okay. Now what he did was, he took a very smooth marble ball and he dropped it from one end of the plank. It came rolling down and it went on the other side, just a little bit lower than the actual height. So if this was going up till very top, this is not at the top, just a little bit lower the actual height. Then it goes down once again, it moves over here, and then it goes once again over here, and therefore it comes down slowly and slowly. Okay, so in the first case we know that the ball actually went to the same height that it was released from. We know that in reality there is a friction force that is stopping the ball from going to the very top. Understood? Now what happens is, he changed the angle of the plank over here and he took another plank. Now what he did was, he increased the height of the plank like this. So there is a new plank and this one is at a 60-degree angle. So much higher than the previous one. Now he released the ball once again. The ball came down, but it did not go till the very end. It went up till over here. So he deduced that even though the ball did not go to the actual end of the plank, it still went to the same height where it was released from. So the ball was released from this height. Suppose the height is h. We don't know, whatever it is, but it is the height h. So the ball will reach over here to the height h. Previously it also reached to the same height. Well, you can say almost same height. Same thing is happening over here again. Now he did another experiment, which he took one more plank at a different angle, that is at a 30 degrees. Much far away, at a 30 degrees. Once again the ball will go to the same height. This is what Galileo deduced. He deduced that the ball will reach the same height no matter what. Whatever the angle of the other plank, it will try to reach the same height. At the end of this, he gave something. If we remove the plank completely, and the surface is really smooth, he said that when we release the ball, it will obtain a certain speed and the ball will keep on moving forever until it reaches the height h. So the ball will try to reach the height h, but if it does not find the height h, it will try to keep on moving forever. But we know that it is not actually possible. There is a friction force always trying to stop the ball when it is moving on the smooth surface. Okay, so if we find a surface where there is no frictional force, then the ball will keep on moving forever. This is what Galileo showed or demonstrated in his experiment. Now Newton, the three laws that we are going to study are are given by Newton. Okay, so the Newton's first law of motion, he studied Galileo's experiment and he came to a conclusion that it is not just about the planks, it is about any object which is in motion. Okay, so suppose we have a moving object or a stationary object over here. Newton said that this object is not going to move unless any external force is applied. Unless any external force is applied, this object is not going to move. And that force should be unbalanced because there is static friction that we studied in the previous video. So if an unbalanced force is applied on that object, then and then only it will move. Or on the contrary, just like the ball. If there is no force, if there is no unbalanced force acting on the moving object, then the object will continue to move on. Okay, so if the object is stationary, it will remain stationary, and if the object is moving, it will continue moving. And the same thing was happening in Galileo's experiment. If there is no frictional force, then the object will continue moving. But there is a frictional force which is stopping it. So Galileo's first law of motion states that if the object is stationary, it will remain stationary, and if the object is moving, it will continue moving. It continue to move on unless any external unbalanced force is applied. I hope it is clear to you, students. You can pause the video and reverse it once again, and if you have any comments or any doubts, you can ask them. I'll be happy to answer. I repeat the first law of motion. It states that the object in rest or stationary will remain in rest, and the object in motion will remain in motion unless any external force is applied. So the object will keep on minding its own business unless it is disturbed. So it is just like us. The object in rest will remain in rest, and the object in motion will remain in motion unless any external force is applied. Okay? We continue this topic by simple experiments. Everyone has played the game of carom, I think. Okay, so one of the coins that we play on the carom board, unless it is hit with a striker, it does not move. Okay, it remains in the stationary position. Other thing is, you take a glass, and this experiment can be done at home. You take a glass and place a piece of paper on top. Okay, now place a coin or any other object on it and move the paper very quickly. So what happens is, this coin will fall in the glass. You have to move this paper very quickly. Okay? Move the paper very quickly. Now how does this happen? And why does this happen? It is because we are applying force on the paper and not on the object kept on top of the paper. So what happens is, as soon as you remove the paper quickly, the static friction does not have the time to oppose the object. So the object which is stationary, it wants to remain stationary, and therefore it is not moving with the paper, and it falls down in the glass. So this is the experiment to show the first law of motion. I hope it is clear to you, students.